Video 3, so vaporizers and the altitude. This is one of those fun facts that the very few things that people who practice anesthesia may remember or may appear on boards. Remember, DES is different. When in doubt, especially when you're studying, like those kind of like red herrings there. So vaporizers and the altitude. So the amount delivered is decided by what we set the dial. So the dial the vaporizer specifies a certain volume percent. So I'm asking a certain percent to merge with my gas flow and deliver to the patient. So the concentration delivery method. So SIVO and ISO, modern, automatically adjust. So not a problem. Don't need to worry about it. They're built this way. Delivered partial pressure is the same no matter what the atmospheric pressure is. If not, then it'll be a little more complicated. So they're SIVO and ISO, the variable bypass vaporizers, the flow over gas, they have the carrier. So DES is designed differently. Like I said, it had to be held back, so there's no flow over. Instead, you're injecting DES into the carrier gas. So it's a dual gas blender, no flow over, so it's injected. So that is the flow over on the first picture. The second picture is DES. So you see the flow meter on the far left, the DES getting bubbled up, and the control dial controls how much the vapor is going to enter the gas flow. So DES and the altitude. So again, this is definitely on your boards, going to get brought up. And also, if you want to take that trip to like Denver, Colorado, and practice anesthesia there, you need to keep this in mind. So with DES, no matter what the altitude is, it will maintain a constant concentration of vapor output, but not a constant partial pressure. So at a decreased atmospheric pressure, the partial pressure will decrease. So depending where you're at, you need to know this. So just learn the different altitudes of different cities in the United States. Like I'm just going to give you a city, and then you just have to remember the altitude and the atmospheric pressure. And then I'm going to ask you how much DES to give. And that'll be worth 90 of the 100 points on your final. So the equation on here in bold. So the DES altitude mass. So your required dial setting is your normal dial setting, whatever you would put on before, times 760 divided by the new altitude. So in the example, which put it here, so we put it at 6% of what we want, times the 760 is the atmospheric. In Vail, Colorado, it's 574. So then your dial, 7.9%. So, I mean, you have it on your screen. Hopefully you're following along. So, just learn, atmospheric pressures of different cities. Alright. So what else should you know? So the vapor pressure math, its relation to one another. Like just DES having the higher vapor pressure has a lower boiling point. Dalton's law, partial pressure, always know that. Change in the altitude, it's always DES. Just knows what makes DES different. So the vapor pressure math. So they're kept in the vaporizers. It's a closed system, so nothing just kind of negligently walks away. Mixing with the fresh gas flow. So Dalton's law, each gas in a mix exerts its own partial pressure. So it makes this kind of easier. So like the example, air, 760 millimeters of mercury, 21% of that is oxygen, so 0.21 times 760 on the slide here gives you roughly 160 millimeters of mercury, and the remaining 600 is roughly nitrogen. Nitrogen 79% of the atmosphere, so 0.79 times 760 gives you the pressure exerted by nitrogen. So the vapor pressure math, so the vapor pressure of the agent divided by the container pressure times 100% equals percent of added agent. So on the previous slide here, so SIVO, so we're at 20 degrees Celsius. So SIVO, vapor pressure is 170. So that's the container pressure. So that's why when we got the max delivery, that SIVO could get 22%. So, kind of great handwriting, that's why I make slides. So, off the slide here. So if it was ISO, it'd be 238 divided by 760. Does 669, so that's how we get all those numbers from earlier in the slide. So, how much liquid agent does a vaporizer use per hour? So this is from the Mike Deutsch, University of Detroit. Like I said, a long time ago. So the Ernworth and Eisencraft 1993 formula. So 3 was constant times your fresh gas flow. So whatever you're running this as, times the volume percent is equal to how many mLs of liquid used per hour. So most volatile agents estimated to produce about 200 milliliters of gas for each milliliter of anesthetic. So how long will 100 milliliters of SIVO last when given at a fresh gas flow rate of 3 liters per minute at 2%? So the 3 is constant. Fresh gas flow is 3, so 3 times 3 times 2, because of 2%. So 9 times 2, so 18 milliliters of liquid used per hour. So, and 100 milliliters of SIVO, we're using 18 per hour, so roughly 5.5 hours. For shorter cases, not a problem, but for some of those ortho cases, they can be pretty in-depth. It can last several hours, so you might have to switch it out or refill on the fly. So vapor pressure of isoflurane 20 degrees Celsius, 32 kilopascals, so it's just kind of using easier than the millimeters of mercury. So the ambient atmospheric pressure is 100, so the concentration is 32% in the container. So the control valve is set to allow 5% of the incoming gas flow through the chamber and 95% to bypass what is the resulting concentration. So 32% is 0.32 is ISO, and we're only getting 5% of the carrier. So that's for 0.016 ISO. So 1.6%. I know it's all on the slide too, but really hammering it home. Oh, and that's the last slide. So if there's any questions, obviously feel free to email, like on the Vaporizer lecture. I'll start working on the 119 slide lecture. I'll try to break that up because I have a feeling, when you get into mass spectrometry and the gas analyzers, I just have a feeling you're gonna skip those. I don't know. I just have a feeling. So I'll be sure the important ones that you might actually pay attention to, like a little bit about the blood pressure cuff and the errant line, and definitely like the ECG. Gosh, the biggest thing of contention of where you place these patches, da 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 da. So I'll break them up kind of by group like that. So any questions, feel free to contact me.